Please, panelists, come on up to your seats. I feel like a game show host. Well, hello, everybody. It's so wonderful to be here back in my old stomping grounds and to be at a live event and see real faces, at least half of them. I think this is my third live conference now back out of the gates that things are coming back alive, and it's certainly nice and feels good. When IHS contacted me about trying to put together a panel for the conference that was supposed to be in September last summer, because we did a panel, I don't know how many of you may have attended it, in 2019 on the autoimmune epidemic. And I had Yehuda Schoenfeld from Israel over, I had David Perlmutter, Nancy O'Hara, and Aristo Vojdjani on that panel. And it was extremely well received. So we're kind of reprising the panel concept in pretty much the same format. But I asked if we could tackle long-haul COVID, because I think it is really the challenge that we need to rise to. It's the challenge of our time. And these patients will find integrative functional medicine type of providers because they're generally not getting answers when they go through more conventional routes. So this is literally a topic that's evolving by the hour, not by the day, literally by the hour. The conference has probably had enough of me already changing the version of my slides here for the panel, because I probably changed them 4 times in the last 48 hours because something new came out. So hopefully we'll have the most up-to-date information for you. I'm going to introduce each of the panelists in just a moment. But first, I'm just going to lay a little bit of groundwork on this whole issue of long-haul COVID. This was me in late March 2020, but more importantly, this was my lovely wife, Stacy, in March of 2020. She got acute respiratory symptoms right when the big initial wave was ravaging the Northeast. And the last place I wanted her to end up was in the emergency room or the ICU at a hospital in Connecticut in March of 2020. I think you all know what I mean. So we pulled out every stop we could to treat her at home, including bringing oxygen units in from our practice and IVs and doing IV vitamin C and Myers cocktails and using every natural agent and glutathione and all the viral blockers and everything you know to do that we'll talk about to some degree today. But we were doing blood pass-through hemolumin, blood ozone. We were throwing, various off-label prescriptive agents at it to keep her out of the hospital. And we did, with the help of some of my colleagues in my practice. But she ended up developing all of the symptoms that we're going to discuss today of long-haul COVID, and she's been in a battle with it ever since. And although she's much better, she's certainly not like she was before it all happened. And she was, like many of these first wave long haulers, the last person you would think would be the one who got it. She was a very accomplished professional dancer. In fact, she used to dance right in that little building right down the street called Radio City Music Hall. And extremely fit, extremely strong, extremely healthy, perfect diet, and she got long haul. And that was the case with a lot of these people, and that's still an interesting concept that maybe we can talk about why that may have happened. Maybe their ability, their fitness, their ability to perfuse tissues efficiently better than the average bear didn't serve them well. Maybe it hurt them in this, but it's interesting. And I just wanted to, before I introduce the panelists, each one of these panelists has helped me personally with her case. And they were extremely generous with their time, very compassionate, and I want to thank all of you just collectively for doing that. Now, long haulers. When did we first start understanding this whole concept of what would become known as long haul and then later PASC? Well, remember that first wave that hit at least the Western countries in Bergamo, Italy, with an older population, smokers, but people with good diets, people who walked a lot. It just ravaged through that area of Italy. And then they started noticing very quickly that people who survived and left the hospital and returned home certainly did not return to their previous state of health. They were having really lingering, significant symptoms that were severely impacting their life. And they started systematically calling back on them and cataloging, who got better, who was still having symptoms, what symptoms they had. And that's when you first saw some things getting out there to the public that, hey, maybe once you get COVID-19 and you recover from it, you survive the initial acute phase, that you're not necessarily out of the woods. And they started calling these patients back and looking at the kind of symptoms they were having in a persistent way versus what are typical in more of an acute presentation of COVID-19. And many of them overlap, but they have a little bit of a different weighting. But things that you would expect: fatigue, breathlessness, joint pain, chest pain, weird chest wall syndrome type of stuff, that electrical feeling, all kinds of stuff that you're, I'm sure, well aware of by now. And right about that time, it didn't take long, there started to become some stuff popping in the medical literature, more from a hypothesis standpoint. This is in medical hypothesis on this post-viral syndrome in COVID-19. And, this is nothing new. This was observed in SARS-1 and MERS and other viral infections. And in fact, CFS, ME, all those things, this has been, something we've grappled with for a very, very long time. But this was sort of the public's introduction to this whole concept, I think, on a larger scale, that once you have an acute viral infection, it's, and you recover from it, you're not necessarily totally in the clear. In SARS-1, it just didn't infect nearly as many people globally, but a lot of people who were exposed, and particularly healthcare workers who had treated those patients, ended up with long-term symptoms that would be something that would often be classified as chronic fatigue syndrome or myalgic encephalomyelitis. But now when we look at it, through a little bit of a wider perspective, we see that these symptoms are just all over the place. First, the question was, is this a lung problem? Is it a heart problem? Is it a vascular biology problem? Is it a gut problem? Is it a brain problem? And the answer is yes. It's all of those things, right? It's really body-wide. But there's an interesting phenomenon I do want to point out with long haul. Long haul has a strong claim to be the first illness created through patients finding one another on Twitter. It moved from patients through various media to formal clinical and policy channels in just a few months. Patients afflicted with COVID-19 long haul defined COVID long haul initially and actually named it. And there were some advocates in that patient group. One of them is here, Gez Medinger, who has done incredible work out in front of the medical community in trying to define this. And this is the first time it's happened. I don't think it'll be the last time it happened. I don't think, because of crowdsourcing and social media and all that we're going to have these decades-long, situations like we've had in fibromyalgia and CFS and other things, where denial, it's give them Prozac, whatever. This is not a real thing. People are just hypochondriacs. I don't think that game's not going to get played anymore, because the patients aren't going to let it get played. So, and why was this crowdsourcing kind of thing important? Well, when the CDC was starting to begrudgingly acknowledge long-term sequelae of COVID-19, they were talking about certain symptom profiles, and it wasn't necessarily wrong, but it didn't match up exactly with what the patients were saying they had. So learning from the patients out there by data mining from them directly has been very, very valuable in trying to understand this, and I'll have Gez talk about that more in a minute. And then finally, the last thing I wanted to show is you fast forward a year to the spring of 2021, and you actually start now having enough lag time, and there was enough urgency involved that you see formal papers coming out. But, they couldn't call it long haul because that's what the patients pretty much named it. So they had to come up with some fancy new medical term, right? So post-acute sequela of SARS-CoV-2 infection, or PASC, right? So that's the official name, not long haul. But this started to look really at timelines. From running from the acute phase into the chronic phase, what did their PCR and other types of test methodologies look like through that timeline? Which systems or organs were involved? What kind of treatments may have been moving the dial a bit? You started to see some of that kind of stuff come out. So we're here to talk about what the state of this is today. And just like on my autoimmune panel, when they asked me to do a panel on autoimmunity, I sat and I thought who are the 4 people I most want to have on this panel and that I really need to go get? And the likelihood is I'm not going to get most of them, right? I'm going to have to go to, plan B, plan C. Every one of them came and served on that panel, and that's what happened here. So thank you, gentlemen. These guys have come far and wide. Bruce from California. Tom came from Denver. Gez came from the UK, from London, so I think you got the geographic, you won the race there. And Richard, Richard's a New Yorker, right? What did you drive, 2 hours?
2 hours. Yeah.
2 hours, okay. But he's a busy guy, so it's hard to get him. All right, we're going to start with Bruce. If anybody's been following long-haul COVID, you've run into this guy's name. He's done probably the most incredible work of anybody that I know in this whole issue of long-haul COVID. And Dr. Patterson is the CEO and founder of InCellDx, a diagnostic lab that really specializes in immunology and cytokine analysis and trying to mine cytokine signatures, proteomic signatures, and other things to try to help define COVID and find better therapeutic options, and he'll be talking about that more as we get into the panel. Dr. Patterson received his undergraduate training in molecular biology from the University of Michigan in Ann Arbor. He then went on to Northwestern University Medical School for training in medicine. During the early stages of the AIDS epidemic, Dr. Patterson began investigating cellular reservoirs of HIV-1 using molecular and in situ technology patented in his laboratory. Dr. Patterson went on to residency in pathology, focusing on viral pathogenesis. While in his residency, Dr. Patterson determined that enough HIV virus was present in infected individuals to account for the massive destruction of the immune system. His paradigm-altering work was published in Science in 1993. Dr. Patterson later was named chief resident of pathology at Northwestern Memorial Hospital. He's authored over 100 manuscripts and book chapters, and he continues his work on HIV-1 pathogenesis and reservoirs at Stanford University School of Medicine. Dr. Patterson was the medical director of diagnostic virology at Stanford University Hospitals and Clinic, and some of his recent work in long haul has led to sort of a treatment protocol that, is it right to call it the Stanford protocol? Do you like that? No, you don't like
the InCellDx protocol.
Right, exactly. So I'm glad we have that straight.
That's right.
Okay, well, thank you, Dr. Patterson, for
Pleasure.
being here. Now we have Richard Horowitz. I don't think in New York or anywhere in the country, for that matter, Dr. Horowitz needs much of an introduction, but we'll go ahead anyway. Dr. Horowitz is board-certified internist and medical director of Hudson Valley Healing Arts Center, an integrative medical center specializing in the treatment of Lyme and other tick-borne diseases. He's treated over 13,000 Lyme and tick-borne disease patients in the last 30 years and is one of the founding members and past president-elect of ILADS. Dr. Horowitz has published multiple peer-reviewed articles on effective diagnostic approaches and treatment options for Lyme and co-infections. He has served as a member of the HHS Tick-Borne Disease Working Group in 2017 and 2018. He was also co-chair of the HHS Tick-Borne Infection Subcommittee, which gave recommendations to Congress on the prevention, diagnosis, and treatment of tick-borne illness, and was recently elected to the New York State Department of Health Tick-Borne Disease Working Group. He's really dedicated his life to those stricken with this devastating illness. He's been awarded the Humanitarian of the Year Award by the Turn the Corner Foundation, and awards from Project Lyme. He published the first peer-reviewed article in the world literature on the role of glutathione deficiency in COVID-19, which has been cited over 150 times. And he's the author of 2 best-selling books on Lyme disease, Why Can't I Get Better and How Can I Get Better? And now he's released, do you have it with you?
I do.
All right, hold it up. His new book has nothing to do with Lyme disease, I don't think. It's a science fiction climate change novel called Starseed Revolution, The Awakening, which contains innovative scientific solutions for a climate crisis. So good luck with that book. Yeah. All right, Thomas Fabian, we're going to skip one here. Tom Fabian is he's a good friend and a leading expert on the role of the human microbiome in health, chronic disease, and aging. He's the Chief Translational Scientist at Diagnostic Solutions Lab, and his primary focus is on the clinical application of microbiome research in the functional and integrative medicine space. He's worked with a multitude of high-technology laboratories and biotech companies as a research scientist, as I said, now with Diagnostic Solutions. He also serves as scientific advisor for Designs for Health, Inc. His doctoral training was at the University of Colorado Boulder, and postdoctoral training at the University of Utah, focused mainly on molecular biology of aging and longevity. His latest area of interest involves the interaction of the microbiome and the GI environment and the long-term sequelae of COVID-19. Thank you, Tom, for coming.
Pleasure.
And finally, Gez Medinger. Gez is the only non-doctor on the... you got to have a non-doctor. You got to keep it real, right? With a master's degree in engineering from Oxford University and almost 20-year career in the film industry, Gez was intending to start a YouTube channel in early 2020 to run alongside his commercial work in film. However, he ended up launching one of the biggest YouTube sites that has anything to do with COVID-19 long haul after becoming unwell with COVID in March 2020 while he was training for a 2-hour, 50-minute time in April's eventually doomed London Marathon. Gez has put his efforts into becoming a patient advocate for long COVID sufferers, interviewing some of the world's leading clinicians and turning his YouTube channel into a huge resource for patients, conducting over a dozen patient-led studies, working with physicians in the UK to do that. These studies have been very important as we've tried to understand this disorder, and they've been quoted in the global press, including New York Times, The New Scientist, and Men's Health, and his films have had over 4 million views. So that's the panel. Please give them a round of applause. All right, we're going to start with Gez, because Gez is, maybe I'm misspeaking, but the only one in this whole group that has actually been a long-haul patient or sufferer. And he's, as I said, he's done amazing work. His YouTube channel, the URL is there. You might want to check it out. Gez, very much like my wife, was one of these people who was an athlete. He was an incredibly fit person, ended up with long-haul COVID. So, Gez, I just wanted to have you just briefly tell your story a little bit and how you got into being that person that went out and wrapped your arms around these people and started collecting information from them and working with local scientists and physicians to try to help the medical community, actually running out in front of the medical community and understanding and defining this disorder.
So this time 2 years ago, I was out in Los Angeles, I was marathon training, and I was trying to get my second movie off the ground. I flew back to the UK just as London was being COVID was exploding through London. There was no testing, there were no mitigation measures, there were no masks, there was no social distancing. Everything was still open, everybody was in offices. And I became unwell at pretty much the same time everybody else did in London. And most people were recovering fairly quickly. But I got sort of 2 weeks in, 3 weeks in, 4 weeks in, and I wasn't getting any better. In fact, the symptoms were changing, and some of them were getting worse.
How severe? Hospitalized?
Not that severe. Right. I wasn't well, but I was still able to do a few hours work a day. Yeah. A lot of my friends, actually, in the very first week, were much iller than I were. They were like feverish and sweating through the night, and I was like, oh, my immune system's great. I'm fine, I can still go down and do some work. In the second week, I started jogging again, because I was like, I can't lose my fitness, because I've got a marathon to run. Which again now is a terrible idea, and I would advocate for nobody to go anywhere near exercise whilst recovering. But about 4 or 5 weeks in, I noticed a particular type of feeling in my throat and chest, very specific feeling I'd not had for 20 years. And I'd had it previously after glandular fever, and I'd developed post-viral fatigue after glandular fever when I was about 20, and that lasted a year. And I thought, oh God, don't tell me I might be looking at a year of this. So I thought, okay, well, I was about to start this YouTube channel anyway, and I thought, well, I'll just make a film looking at the science about what we know about post-viral fatigue and what we know about COVID-19. So I put this film together and put it out, and I wasn't sure if it would find an audience, but it found a huge audience immediately because there were all of these people out there going, I'm not well, what's going on? We're supposed to get better in 2 weeks, and I'm worse, and the symptoms have changed. And I suddenly found myself in this position of having an incredibly engaged, motivated audience who wanted to understand what was going on with them, and I wanted to understand what was going on with me. So I thought, well, okay, well, there's something I can do with this position, and that is use that audience to collect information and data that I can then look at and try and answer the questions everybody's got about the condition. And I can actually pull all of that and do it incredibly quickly. I could put together a survey in a couple of hours. I can drop it out on all the support groups on Facebook, and I've got, an N of 1,000 in about 2 days. What kind of medical research happens that fast, right?
Did you IRB that, by the way? I'm just kidding, never mind.
So one of the first things I looked at, which everybody was asking, is why are my tests coming back negative for antibodies? And I thought, is there something to this or not? So I, put a survey out there and sort of gathered a load of information, and I found that only 22% of long haulers were testing positive for antibodies. And if you looked at the way that people had cleared the virus quickly, about just over half, 54% of them tested positive, and then people who had asymptomatic infection were even higher, 75%. And that's looking at other studies that were being published. So clearly there was something unusual about long haulers' antibody immune response. And recently, in the last few months, we've had papers coming out saying, oh, look, they do have a different antibody response, fewer antibodies responding to the virus and lots more autoantibodies. So 18 months later, the science is starting to catch up with stuff I was putting out at the time. Right. And I just went from there and tried to answer as many questions as I could with the resources I had available to me.
Great. Well, I mean, once again, I just applaud you for your work. I mean, you've really moved the dial on this, so you made an impact. And I know that from my wife's experience, because she's involved in all these groups, and it all seems to come back to a lot of your resources. So I think it's very important, and I thought it was important to have a patient on this panel and someone who's been through this. As we get into these different discussion points, I'd love your perspective also as a patient. All right, I wanted to talk about where we stand from the standpoint of testing and diagnosis, because as physicians, first thing we grapple with is how do we tell, does this patient have it or not, right? What are the diagnostic markers or signatures of this disorder that we can have some objective, idea of what we're dealing with here? And there wasn't much there at all. There was a lot on, a lot of confusion still, but there was a lot of information and options when it came down to actually testing for the acute phase of COVID, but not necessarily with long haul. And then along comes this guy popping up in everyone's awareness, this Bruce Patterson, with doing exactly that. And this is you got to get this paper and read it, Immune-Based Prediction of COVID-19 Severity and Chronicity, Decoded Using Machine Learning. So here this brilliant guy out in California is looking at cytokine analysis of a lot of these subjects with long haul and versus controls, and doing all the due diligence and doing it scientifically the right way, and using modern computational biology and machine learning, trying to tease out what's different about the immune response in these long haul patients, and trying to actually give physicians and clinicians something that we can turn to try to diagnose this. And this is actually used with permission. My wife Stacy's Incel DX, I think her second or third one along the way. She has one that's pending. I got to get the results from you. Bruce, maybe you can talk just a little bit about your work. How did you get dragged into this, and then what have you done to get to this point?
Yeah, well, I'd love to follow on with what Gez said, because around the same time, which was spring of 2020, we were finishing up 3 trials on CCR5 antagonists in acute COVID, and those trials stopped at day 28. And what we were finding was with these patients who would call, we were doing over 150 different biomarkers at the time, and these patients would call at 40 days, 60 days, and what we noticed is they were better, they were out of the hospital, but by no stretch of the imagination was their immune system anywhere close to normal. So around the same time that Gez was seeing this amazing symptom complex and these people talking about this, we were really saying, we dug a little deeper and said, wow, their immune system is completely messed up. So what we did is we got this cohort of long haulers, and we compared it to mild to moderate and severe acute COVID, and it was by machine learning and artificial intelligence, completely different. It was a different disease. Okay, and so there was basically this cytokine switch from innate immunity to more adaptive immunity, but this adaptive immunity was damaging. And that's what we published in that first paper. And I remember we treated a congressman's son effectively early on with some drugs that obviously would address individual cytokines, and I'll get into that a little bit more now this new study's out. But, so this congressman knew that we got his son back to almost pre-COVID levels, and he sat in on a hearing at the NIH where Francis Collins was testifying and said, there's no abnormalities in long COVID. There's no cytokine abnormalities in long COVID. And this congressman basically stood up and said, excuse me, Dr. Collins, but have you seen the work of Dr. Bruce Patterson? He says, no, I haven't. And so Francis Collins and I went back and forth, and I shared that paper in Frontiers in Immunology with him. And now I think it's widely accepted that there is significant cytokine and immune abnormalities in long COVID, and it's a separate entity from acute COVID. And I won't go into it now, but we looked into the potential mechanisms. But what's so important with our recent study, which was an outcome study based on the treatment protocol that we used on pure COVID, and I'll talk about pure COVID and what we call PASC and PASC plus in a moment. But when we looked at pure COVID, pure PASC, and treated them, all 5 of the major symptom scores, fatigue, dyspnea, which is shortness of breath, dysautonomia, neuro, and cardiac, all of them improved statistically significantly over 6 to 12 weeks of therapy. But what was most important was by running these biomarkers, our statisticians were able to correlate cytokines and which cytokines with specific symptom improvement. So I can tell you right now, as we sit here, and this paper just came out in preprint, that TNF alpha and interleukin 2 are the ones responsible for fatigue. Soluble CD40L, SCD40L, and VEGF are responsible for dysautonomia. And you correct those, and the symptoms follow. And I think that is the epitome of precision and targeted medicine. And that's where we should be in COVID. If there's one comment I have in the management of COVID and long COVID, it's the fact that we are not using precision medicine to make decisions. In cancer, you will not take a drug until a foundation medicine or a GRAIL has told you that that drug is going to work against your specific tumor. We are doing the same thing at IncellDX for long haulers and now post-Lyme, ME/CFS, and post-vaccination long haulers, and I'll get into that in a moment. But that was the genesis of taking these 150 biomarkers and with the aid of machine learning and computers deciding which ones really define long haulers and defined what the pathogenesis of long haulers is.
Awesome. Just incredible work and exactly the stuff I geek out on. It's perfect. But we're going to get to your new study on the treatment interventions and how that affects these different biomarkers in a moment. I want to turn to Dr. Horowitz. Dr. Horowitz, brilliant diagnostician, brilliant clinician with so much experience treating the chronic sequelae of infectious disease. Big reason why I needed to have him on this panel. But also to directly address the issue of the overlap that seems to be there and how long haul presents and folds out with chronic Lyme and chronic tick-borne disease and other kind of stealth infections and chronic infections. And some of the questions that I had for Richard very early were, how do you differentially diagnose, especially in this region, right? Is it someone with some presentation of Lyme or tick-borne disease that's in a chronic state versus long haul? Could they have they had COVID, but now, they have chronic sequelae of tick-borne disease, and it's just assumed to be long haul? Is there a reactivation because the person's now in a vulnerable state of Lyme or tick-borne illness or other ubiquitous chronic viruses and things like that? And how do you ferret this out? And is there any lessons from the treatment of chronic Lyme and tick-borne disease and the management of it that can be applied to long COVID? So I know that's a bunch of questions in one, but I'm sure you're up for the task. So what have you seen?
So picking up what Bruce said, I published 2 articles a few years ago on precision medicine. Precision Medicine 1 and 2, and the model, for those of you who've been following the work over the years, is there's a 16-point model that I developed called MSIDS, Multiple Systemic Infectious Disease Syndrome. So when my Lyme patients, and one thing that has to be clear is a lot of the patients coming in to see me have chronic Lyme, but then they get COVID, right?
Right.
So I'm already dealing people who have not just Borrelia burgdorferi sensu lato, but they've got Babesia microti, Babesia duncani, Bartonella, which increases VEGF. I'm going to talk to you about in a second about this. But these same people have autoimmune markers, right? They have glutathione deficiency. They have autoimmune markers with ANAs and rheumatoid factors. The same kind of things we're seeing. But the difference is that I saw early on, and this is more with Delta than with Omicron, is that my patients would have a chronic fatiguing musculoskeletal neurocognitive presentation that got worse when they got it. But early on, of course, it was the anosmia and dysgeusia, the loss of sense or smell or taste, which you don't get with Lyme disease. Right. That previously was seen with neurocognitive issues like with Alzheimer's, right, in the past.
Right.
But with the lungs, you can get cough and shortness of breath with babesiosis. You can even get ARDS, by the way, with babesiosis and malaria, although we don't see it often. But my patients, the reason I knew to use glutathione early on is because having done so much Lyme over the years, and this was early on in the pandemic, I looked at the cytokines that were coming out with COVID. And interestingly enough, it was TNF-alpha and IL-1 and IL-6 and IL-8 and IL-10 and IL-17 and TGF-beta-1. And it's like, oh, I've seen those before. Those are the same ones I treat with Lyme. So, what we did in Lyme patients with Herxheimer reactions, which are cytokine storms, we did for the COVID patients. So I blocked TNF-alpha and used, for example, blocking NF-kappa B with N-acetylcysteine, alpha-lipoic acid, and glutathione. And interestingly enough, when you start blocking NF-kappa B, which raises IL-6, lowers glutathione, right? If you block NRF2 activation, you need that to lower inflammation. If you block that, you also get lower glutathione. And similarly, they were showing with the NLRP3 inflammasome pathway that was being affected. So we used things like curcumin and broccoli seed extract for NRF2. We used melatonin to block NLR3P inflammasomes. And apart from the glutathione article I actually published a 3rd article in the literature on ivermectin early on in Medical Hypothesis. So before I knew you and knew your work, we were using ivermectin and glutathione and NAC and alpha-lipoic acid, and my patients were getting better. In fact, we've treated probably 125 acute patients. None of them have gone on to long hauler. So if I used ivermectin 0.2 milligrams per kilo early on with all of these supplements that stopped NF-kappa B from activating, and I got the NRF2 pathways to work, these patients did quite well. But we noticed, especially early on, that oral or IV glutathione was making a difference. And I was using it for years for Lyme for Herxheimer reactions. I didn't know that glutathione had antiviral effects. So the lungs have 140 times more glutathione than any place else in the body, right? So when you get this cytokine storm and free radical oxidative stress, if you don't have enough glutathione, you're going to have problems. Right. So that's how we kind of got into it. But the difference with chronic Lyme, just so you're clear here about the differences, the Lyme patients generally have good and bad days where the symptoms come and go, but the hallmark of chronic Lyme is migratory joint pain, migratory muscle pain, and migratory nerve pain, tingling, numbness, burning, stabbing sensations. And if you do a medical search, when we published the first validated Lyme questionnaire back in the International Journal of Medicine with Newpolt's researchers about 5-6 years ago, we found at that point that migratory pain was the hallmark, and the only other diseases in medicine you get it was hepatitis, acute rheumatic fever, Crohn's disease, gonococcal arthritis, Reiter syndrome, and lupus. That's it. Those are the only other diseases in a medical search So if you ask your patients if they have migratory pain and they've gotten long COVID, right? And these were the patients, and I know you've seen this, the worst patients were the ones with autoimmune markers, type 2 diabetes, RNA virus in their blood, and they reactivated their Epstein-Barr. And we were seeing reactivation of the Lyme in the blood, Babesia, Bartonella started coming out with Bartonella fish. So when COVID came, everything started to reactivate at the same point in time. So basically, all of the things I've done for Lyme over the years helped me to kind of figure out the pathway for COVID.
Yeah, it is sort of a perfect storm, and it would be silly not to go learn from those lessons in managing these other conditions. But it's amazing how much that doesn't happen. And a lot of researchers right away, even when COVID started coming out, they started looking at repurposing drugs that we've used for a long time for other things, right? But and we'll talk about this a little. I don't want this to devolve into the politics of everything in COVID, but it seemed like there was just an agenda that was dead set against any older drug that was not on IP, not making anybody lots of money, being the hero in any of this, even if it was, right? That story was not going to be told, and we'll get into that just a little bit.
I'd just like to add, can I
Sure.
add one point
Sure,
to
absolutely.
what Richard said is all of what you've seen, we've seen. And you know what the big issue is? People don't realize that in acute COVID, your CD8 count is as low as the CD4 count in AIDS patients. So the CD4 T cells and the CD8 T cells together fight off intracellular organisms, usually viruses, and cancer. And in AIDS, the CD4 count is low. In acute COVID, we were seeing the same severely depressed levels of CD8. So you're getting reactivation of EBV, herpes, etc., reactivation of potential Lyme organisms, reactivation of ME/CFS organisms. That's the whole reason, and that's why these classifications, if they have EBV or any of these organisms, we call those PASS plus. They're not actually PASS because, like you said, Dr. Brady, I mean, the association between having COVID and then having these symptoms, it's because of the low CD8s, it could be reactivation of any of these organisms. We're treating about 1,000 Lyme patients right now, and their immune profile is very similar to long COVID, except they have high IL-6 and IL-8, which causes joint and muscle pain, and VEGF, which not only causes blood vessel proliferation, but it causes peripheral neuropathy. So you get the numbness and tingling, you get all of the things that go along with that. And vasodilatation. What does vasodilatation do? Drops your blood pressure. What does drop blood pressure do? Increases your heart rate. POTS. Yeah. We hear this term POTS all over the place in long COVID, when in fact it's actually it's a compensatory mechanism that is making up for the fact that you're vasodilated and hot and cold insensitivity, all of that stuff.
Yeah, we're going to delve a little bit more into that POTS syndrome and just autonomic dysfunction. Wanted to turn just briefly to Tom here, just to bring in the microbiome and the gut. We knew very early from our work in the laboratory at DSL that we were doing the only quantitative PCR SARS-CoV-2 tests in stool, and worked a little bit with FDA on looking at some municipal surveillance, on trying to get an idea of how much penetrance this had in different communities, looking at the fecal samples from the municipal sewer systems, to trying to screen FMT donor material. So we knew very early on we can find this in the stool before we could in the lungs, and we can find it in the stool long after it left. You can't get it in the lungs. So GI was a big reservoir of this, and with this whole gut-brain connection, how much is some of this persistence in long-haul COVID related to dynamics in the gut? We knew that there was not only a gut-brain connection, but a gut-brain-lung connection, that changes in the microbiome or different sort of enterotypes or signatures in the microbiome was able to somewhat predict the path people went down in acute COVID, who was at risk of really having a very bad outcome. But when we pivot now until long-haul COVID. You see, this was just a couple days ago it came out, right? Pilot studies suggest long COVID could be linked to the effects of SARS-CoV-2 on the vagus nerve. And the vagus nerve, of course, is, controls a lot of different things. You get into POTS and you get into, heart rate and blood pressure, but gag reflex and many other things. And the vagus nerve is considered that, that conduit between gut and brain and gut and nervous system. So, Tom, do you want to comment on that first, and then anyone else maybe can jump in to that?
Absolutely, yeah. I'd like to put it in kind of the bigger context of sort of the gut, brain, gut, lung, you name it. I mean, the gut is pretty much influencing health of almost any organ, and that's really largely centered on the gut-immune connection. So there's really, when you think of the gut microbiome and imbalances in the gut microbiome and how those have been characterized to be related to chronic disease, acute disease as well, and susceptibility, a lot of that has to do with the makeup of the microbiome, but in particular the metabolites that they produce. So those are really two mechanisms, is how do the various types of microbes interact with the immune system, and then also the metabolites that they produce, how do they also influence the immune system, everything from neurotransmitters in the brain, for example. So this is becoming more and more characterized over time. One of the common features that we see in a really long list of chronic diseases, particularly autoimmune diseases, for example, is a lack of some of the key keystone species, beneficial species. So just to mention a few that I think a lot of people are familiar with, Faecalibacterium is kind of the canary in the coal mine. I mean, it's something that you see deficient all the time. We do a lot of gut testing, of course, at Diagnostic Solutions Lab, and I review results with clinicians every day and see this pattern in a very long list of chronic diseases. So that's one of our three main dysbiosis patterns that we see. Is a deficiency type pattern, often involving keystone species. In fact, a recent study actually really underscored that, where they characterized basically in a very large population the immune dynamics driven by different types of gut dysbiosis.
This paper I linked here, I think that I have up, is doing some of that gut microbiota dynamics in prospective cohort of patients with post-acute COVID-19, and they talk about Faecalibacterium improves in the CI.
Absolutely.
Yeah.
Yeah, and we know that some of the mechanisms evolve. For example, Faecalibacterium is one of the major butyrate-producing bacteria. I think, again, a lot of people are already familiar with this. There's quite a few, but there are many mechanisms besides butyrate for how the microbiome can promote essentially immune tolerance, T-regulatory type responses, which is really central to keeping or maintaining immune balance. But the flip side of that is, particularly when you have a lack of bacteria, you have something that comes in and causes inflammation, such as a viral infection, for example, that can upset that balance, and you can have an increase in opportunistic microbes that then can drive further this imbalance between the Tregs and then the Th1 responses, Th17 type responses. We also have a cytokine test that's been around for a few years. We see these patterns quite frequently in patients that have chronic conditions.
Yeah, I'll show some of those correlations, but this study is interesting. It goes back to, Bruce, what you were talking about, where you were able to sort of correlate different cytokine patterns with specific symptoms within the constellation of COVID long haul. They're kind of doing this with the microbiome here. They're looking at different opportunistic pathogens here, Streptococcus anginosus and other strep species with the fatigue, more of the neuropsychiatric and fatigue symptoms, where they're linking other organisms with different symptoms. So they're kind of really trying to tease this and pick it apart. I'm not sure, as clinicians every day in our office, we were able to go to this kind of level. We're not able to do this deep, data mining type of thing, but we can certainly keep in our mind we have to optimize gut function and the microbiota and the gut environment as part of treating these patients, because, as you said, it's not just the composition of which organisms are there that's interesting. It's changing functionally what's going on in the immune response, and that's what this paper is talking about, actually the microbiota regulating how we react to viruses in particular.
Well, what's interesting is they mentioned interferon in this particular paper, and interferon and IL-2 are the numerators of the long hauler index.
Right.
So it's interesting that that no matter what the source, that's the composite that has gone into our algorithms, and maybe it is produced by the gut in large amounts, which is that switch, because you don't see the type 1 cytokines, IL-2 and interferon gamma, are not high in acute COVID because, of course, it's an innate immune response. And so you have more of the TNF alpha and the IL-6 because it's the macrophages that are driving that innate response against an emerging infection that your body's never seen again. Then what happens is you start to bring in more adaptive immunity and have the interferons and the IL-2s being upregulated.
And just showing like clinical examples of this, how some of these microbiome panels can line up with the cytokine that you see in these patients with these difficult disorders. So I really think, and I'd love to kind of collaborate a little bit with Bruce a little bit more on cytokines and the microbiome, how we can use them together in a multi-omics type of approach to get there. I did want to bring up an issue of how long-haul COVID has been treated. Kind of initially ignored, then kind of almost aggressively, diminished, and now it's getting a lot of press. But the press tends to be, like the press usually is, like very dramatic and very kind of almost in a scare tactic kind of way. And you see things coming out, and the average public is seeing these things. These are things that are popping often in peer-reviewed medical journals, but then there's a press release or there's some sort of media attention to it. So they're seeing things like people who get COVID and recover from it may have long-term lung abnormalities on some of these advanced, like hyperpolarized xenon MRI studies showing persistent damage in the lung tissue after COVID, particularly with people with breathlessness on a chronic basis. And then they hear about microclots. They're worried they're going to walk around and have a clot and have a stroke, right? Or now you see, this was just the other day, how past pandemics may have caused Parkinson's, right? And they actually looked at the Spanish flu, that there was a window of, it was fairly younger individuals when they were still somewhat in a developmental stage in their nervous system and in their immune system, when they were exposed to the Spanish flu early in the 20th century. That cohort went on to have a strikingly increased level of Parkinson's when they got older, but they were young Parkinson's patients, but it came later. So the whole question is, how long is this COVID thing going to be with us when it comes down to long-term incidence of autoimmunity, Parkinson's, dementia, cardiovascular issues? This was just the other day, February 10th. Heart disease risk soars after COVID, even with a mild case that someone recovers from when someone doesn't have long-haul COVID. So the public is out there like really, really frightened about this stuff. So I guess my question for the panel, and I talked a little bit at the CASI conference that I chaired in Arizona in October with Dale Bredesen about the idea of how much more dementia are we going to see, early atypical dementia after COVID-19. He was extremely concerned about it. What is the thoughts of the panel on these long-term kind of epidemiological trends that may not unfold until 20, 30, 40 years from now?
One thing that came out just recently in the literature that was concerning regarding that was the amount of tau protein and neurofilament light that started showing up in these patients, which are the markers for Alzheimer's.
Yep.
So there's clearly a lot of brain inflammation, and in Lyme patients, we've been using LDN, low-dose naltrexone, for years to shut down microglial activation. One of the interesting parts about glutathione in our Lyme population is about 75% when they have Herxheimer reactions or neurocognitive issues, we give them 2 grams of glutathione, either IV or oral, every day. And a third of them will say, I feel a little better, my brain fog's better. 2/3 say, I'm moderately to, oh my God, my brain fog is cleared. Now, I've never actually looked in the urine after we've done this to see what kind of neurotoxins are being pulled. But when you look at the studies that came out on pollution, right, in these highly polluted areas in the people that had COVID, whether it was wildfire smoke or air pollution, the mortality rates were high. So the problem right now that I'm seeing is that when you've got infections like Lyme, which is in epidemic proportion, and you're dealing with all these environmental toxins which are known to cause autoimmunity, and Borrelia has been well characterized to cause autoimmunity, I think we're going to be looking at actually a lot of people, because the prior numbers I saw was 46.5 million Americans with preclinical dementia. This was years ago. So now that you're talking about this kind of neurocognitive deficits, I think we're going to be looking at a big... In fact, they said some of the people that didn't even think they had long COVID, they looked at their memory concentration and found it was off.
Yeah, and they're like, this heart disease risk isn't people who recovered from COVID and have long COVID. This is just anybody who had COVID and recovered, right? So that run those numbers, right?
Well, we in our new study, we actually pulled a lot of our information on the two drugs that we use, the CCR5 antagonists and statins, from the cardiac literature, in terms of, you know, the fact that we found that long COVID is really due to vascular inflammation, and that's a setup for the microclots, but it's also a setup that is seen in atherosclerosis, and we're actually using drugs that prevent the accumulation of these non-classical monocytes, which are A, pro-inflammatory, and B, they actually carry the S1 protein of SARS months and months and months, if not years, after initial infection. And they bind to the blood vessels through a pathway called fractalkine. Statins reduce the level of fractalkine and interrupt that interaction, reduce the vascular inflammation. And that's why they've been used for decades in heart disease. And in fact, more or less, COVID and long COVID are causing the type of vascular inflammation that's not unlike the vascular inflammation that leads to atherosclerosis and clotting. And so we were really the first to identify that the SCD40L, which is a marker we have in our panel, which is associated with, is actually produced by platelet activation, which then brings in von Willebrand factor and other clotting cascades. And also activated platelets produce CCL5 or RANTES and bring in more immune cells, and they form a nidus for these microclots. And so we're seeing a lot about, you know, some of these apheresis and ways to vacuum out these microclots, but you're not removing what caused them in the first place. And so, you know, you're going to keep
temporary effect,
keep getting your microclots removed while you're not removing the actual vascular inflammation that's causing them. So, you know, and then the other thing is Alzheimer's has been associated with RANTES or CCL5 and cytokine abnormalities. We actually took homogenates from an Alzheimer's patients from late disease and mild disease. We took homogenates of the brain and ran our broader cytokine panel of 150 cytokines, and we found that IL-18 and GCFS were two cytokines that determined they were almost reciprocally regulated. You know, one was high, I can't remember which one, like IL-18 was high in advanced disease and GCFS was low, and vice versa in mild disease. So clearly there's an inflammatory association with brain disease and cardiac disease, which is part and parcel to what both acute COVID and long COVID are doing.
I was really eager to hear Dr. Mark Houston later in the conference on his talk on the endothelial glycocalyx, because I'm just wondering structurally if you can identify any actual damage in the glycocalyx, which, you know, especially with all the microclotting and this disorder is like a vascular biologist dream or nightmare, I guess, one or the other.
Right.
Which brings me to another point. I don't want to spend too much time on it, but, you know, also at Cassie in October, the other, besides Dale Bredesen, my other keynote was Dr. Bob Navio from UC San Diego, talking about the cell danger response and how, you know, he's kind of looking at a whole different model of pathology, right, where you can get into these patterns where the cell's locked in this danger response, never gets to the full healing response. Leakage in the mitochondria, ATP released, and the whole cascade of damage that can happen because of that. Do you think there's any benefit at looking at this from a different perspective, like from this cell danger response perspective? And have you seen any therapeutics that go at mitochondrial function be helpful in these patients?
Yeah, I spoke to Bob at one of the prior conferences, and I don't think there's any doubt. I mean, with the free radical stress, you're getting mitochondria have no way of protecting themselves.
Right.
And in some of our patients, the Lyme patients, that most of our patients do get better now, by the way, with the newest treatments that have come out the last few years, or biofilm combined with persister drugs like dapsone, which I had published in the literature.
Yep.
But the extracellular ATP that Bob is talking about that goes high, you can't get any drugs. I spoke to Bob about this, right? You can't really get any drugs to do it.
Right.
He's used them in the autism population. The closest I saw for dealing with that was actually the broccoli seed extract, sulforaphane glucosinolate. John Hopkins had published studies that at 300 milligrams, some of these autistic kids got better and looked like there might have been an association with cell danger and extracellular ATP. But I've used glycosylated phospholipids, CoQ10, acetyl L-carnitine, NADH. I've used mitochondrial regeneration.
Yeah.
And there's definitely a subset of some of these patients that do respond to it. And it's part of the 16 MSIDS model that I use. So I wouldn't say I've seen a lot of help with it, but I've definitely seen some patients respond.
I see it move the dial somewhat. They're less fatigued. Maybe some things lift, but it's not sort of, this solved it, right? It's not curative. Gez, what have you seen with the patient population out there with long haul, we think of, the cognitive dysfunction and the fatigue and a lot of these sort of debilitating symptoms, yet it doesn't get someone into an acute kind of medical crisis situation. How much have you seen them progress on to actual heart disease or cardiomyopathy or serious pulmonary problem? They're all going to cardiologists and they're getting the full workup and everything's normal, right? But they have terrible tachycardia, particularly episodically at night, chest pain, they feel like their heart's going to explode.
Well, the answer is, I think it's still a little bit too early to say. I do hear of it, but it's not happening in huge numbers just yet. There is there is the odd horror story of, my heart was fine last year, I had a full scan, I went this year, and suddenly now, big problems.
Right.
But it's not, fortunately, fingers crossed, we're not seeing it on a wide level yet, but I am very concerned about what we're going to see in 5 or 10 years on all sorts of different levels, whether it's cardiac or neurological or cognitive. Yeah.
Well, we're talking about this cardiovascular connection. I found this paper fascinating, so I sent it to you guys, I think, just a day or two ago. I don't know if you got to look at it on the plane. Persistent exertional intolerance after COVID-19, and it's looking at, it's two pulmonologists, one a Harvard pulmonologist, David Systrom, and then Inderjit Singh at Yale. And these are two researchers that are some of the few pulmonologists that have their hands on invasive exercise, diagnostic technology. And they were looking at long-haul COVID and seeing a lot of similarities to people who had been previously classified before COVID with ME/CFS. And some of the things they were finding here are interesting. Markedly reduced aerobic capacity, peak VO2, less than 80% expected. So this indicated that the long-haul patients were unable to produce normal amounts of energy through aerobic, pathways. And the Krebs cycle was clearly struggling to make energy. But they had high blood oxygen levels at the moment of peak exertion, which suggests that they were oxygenating, but they weren't transferring, right? There was no normal tissue perfusion. And that was backed up by the finding that they had increased oxygen saturation found in venous blood. The blood coming back to the heart, which should be deoxygenated, was still full of oxygen. So it wasn't getting off-ported, right? It was coming back home. Hyperventilation that you see, and you think of CO2 as a byproduct of energy production that you have to get rid of, or else it's toxic. But if you hyperventilate, you can actually drive your CO2 too low. One of the hallmark symptoms of that is fatigue and brain fog. And then another interesting thing, significantly reduced left-sided filling pressure. Basically, the blood coming back was still oxygenated, but there was less of it. It was leaking. This was a case for leaky vessels, right? And they kind of summed it all up pretty shockingly, saying that what was happening in muscle metabolism was akin to heart failure. It's what you see in heart failure, and that there was actually deficiencies in enzymes responsible for aerobic activity and energy production. So the whole muscle metabolism was just a mess, almost like body-wide heart failure. What do you guys think about that? Have you seen that? Do you think it kind of makes sense with the symptoms?
One of the things that's been showing up, I don't see it as much because the acute patients I treated did not actually go on to long haulers, but the ones I did treat from other practices who took ivermectin and glutathione, the ones that we were using, definitely got better. But mast cell activation actually seems to be, and in Lyme they call it PIMCAS, pathogen-induced mast cell. It seems to be happening according to Theodoris at Harvard. They seem to be also seeing it, and they're using antihistamines now, right, for some of these patients with
we're going to get there.
Are you going to get to with luteolin? That they're showing actually that just like we see it in mold toxicity, just like we see it in Lyme, they're starting
lessons
to see
to be learned from all of this stuff, right?
It's starting to show up here also.
And as Tom mentioned, it's not just the microbes in when we get to the gut connection again, but it's the metabolites, right, of those the gut metabolome. Here, this is an interesting paper talking about, if you change the microbiome, you're changing the level of production of things like short-chain fatty acids. And these short-chain fatty acids get through, portal circulation, actually get in small amounts to the muscle, and it changes muscle physiology. So when you change the microbiome, you're directly changing muscle physiology. Have you seen this connection, Tom, in this work? Or?
I've seen some of it, and just kind of tagging on to the discussion about mast cell activation, we see a lot of that just in general in terms of symptoms for patients and what we're reviewing with our tests. But one of the key connections would be Staph aureus. I just want to kind of mention that. That's one of the ones in the gut that's been linked particularly to gut skin issues, gut lung issues, and it's thought to be largely due to superantigens. So I'd be interested to hear your take on superantigens, and I know that they play a big role in potentially in mast cell activation.
Yeah, I mean, at least in our patients, a lot of them end up having leaky gut, multiple food allergies. A good part of my light patients have had POTS way before they ever got COVID, right? So we're seeing a lot of this in our patients. One question I had, though, with the microbiome, in the prior studies where they're looking at Prevotella and Firmicutes ratios in these people who are having autoimmune disease, rheumatoid and MS, they were showing Clostridium species, right, Blaudia species. I saw some of them. Can you speak a little bit about the overlaps from the prior autoimmunity that they used to do at NYU and stuff of what they were finding in the gut and the overlaps that we're seeing with long COVID in the microbiome?
I'm not. Can you repeat the?
So they were showing that abnormalities with Firmicutes and Prevotella species that were showing up in the rheumatoid patients, and MS patients showed like high Clostridium. They were showing. I read some of the papers, and it looked like there was some overlaps with the ones I hadn't seen Blautia before, and some of the ones that you were discussing. But I had seen some of the prior ones, and I was wondering, is there an overlap because they're seeing so much autoimmunity now with long COVID?
Right.
Whether you were seeing
That's a great question. So two of the main categories of products in particular that the microbiome produces, of course, are short-chain fatty acids, but also bile acid derivatives. The Clostridium species are well known, especially particular species, to convert bile acids into particular secondary bile acids that then can have a pretty wide range of effects, particularly through receptors like the FXR receptor, TGR5 receptor. As far as do we see that pattern, I can't say that I've seen enough of that yet to really notice a pattern with that particular species. But Blautia as well, several of those species have been shown in particular to produce these key short-chain fatty acids, but also the secondary bile acids. So that's really, I think, an emerging topic in the microbiome field is how short-chain fatty acids, bile acid derivatives, and others can affect immune responses. But I can't say that I've seen yet particular patterns in that regard with those two.
Well, I want to get into, we're running a little short on time. I did want to get into just this whole concept that, there's this chasm that we all know between medical research and the practice of clinical medicine, right? There's a big delay, big gap. And often, I think medical research is outstanding, and there's so much lessons to be learned there, and a lot of it never gets to clinical medicine, right? For whatever reasons, political, economical, lack of awareness, whatever. So there was always this chiasm between medical research and clinical practice of medicine, but now, making this chiasm even deeper is the influx of politics, right? It seems like science is now camped into different places, right? Which is ridiculous. And we really collectively, as healthcare providers, physicians, scientists, have to make sure this is not allowed to happen, because this can be really bad. What happens the next time a pandemic comes, nobody trusts anything they're being told because they've lost all confidence in public health officials and our institutions. That's a bad thing. We saw this play out. I alluded to it before. Ivermectin was a classic example. I don't want to harp on this, but you have people like Andrew Hill in the UK, right? Big influential person. He's a researcher for World Health Organization. He's a consultant to the Gates Foundation, the Clinton Foundation, right on down. He wields a lot of influence in what drugs are purchased globally, especially in underdeveloped countries, immunization programs and the like. And this was a classic example where he testified openly. He was for ivermectin before he was against ivermectin. Then he was for ivermectin. Then he was against ivermectin. And it all there's a whole timeline of how he's conflicted in so many ways with sponsors and funding and all. It's a mess. So I don't really want to delve too much into that, but let's talk about ivermectin and long haul. I leave the controversy behind of acute COVID and early intervention with it and so forth. But ivermectin and long haul. There's papers out on it. This is out of South America. This is Aguirre Chang. He's put out a lot of information. But Bruce, I know you have feelings on this. Ivermectin and its use in long haul. Now, from the beginning, now, has it changed?
Yeah, I think it's changed as we more clearly define the mechanism of long haul, and our current paper is only on Maraviroc and statins. Ivermectin, we tried. I don't think it worked as a solo agent. Does not work. It's worked for some of our patients. We're now up to 17,000, so we've used it on some patients. And in reasonable quantities, 6 milligrams every 3 days, 9 milligrams every 3 days, 12 milligrams every 3 days, depending on weight. I think some of the doses that were recommended by the FLCCC and others are way too high. And we were finding a lot of patients had GI side effects and neuro side effects. I think it's a good immune modulator. I'm just, the jury's still out for me and I'm actually doing some experiments with the actual virus in our labs right now to see if it truly does have antiviral effects. And I'll give one cautionary tale from my HIV days. I think I was in my 20s, and it was the late 80s or early 90s, and I was growing HIV and infecting T cells in vitro. I used colloidal gold to block the GP120 interactions, and I stopped HIV infection cold in vitro. And I remember going home to my wife saying, "You know what? I just stopped HIV. I think I'm going to win the Nobel Prize."
Yeah, I was going to say that. That was coming.
And I said, and colloidal gold's also being used for arthritis. So I'm like, I think we're there, And sure enough, when we went into patients for a number of different reasons, probably, tropism, which we need to talk about at some point with COVID. But for one reason or another, it didn't work. So I'm always very cautious, and it was crazy in the beginning of the pandemic. All these papers coming out in Nature about this antibody and this compound and this, that, and the other thing working in vitro.
Yeah.
And you know what? It's like you could drop Pepto-Bismol in a culture flask with these viruses and stop it, I'm sure. So you have to be very, very careful about in vitro data. It's a nice place to start to screen candidates, but by no stretch of the imagination does that automatically revert to efficacy in patients.
Let me ask you, though, someone so steeped in research and sort of very conventional research, do you think researchers have just shied away from even looking at the ivermectin issue just because they don't want to be stained by it?
Oh, no. I think, in fact, I'm working with some colleagues at Yale, and we're looking into it. I don't think people have given up on it. I think it's such an interesting molecule, and, the fact that there's reports on both sides, I think, just raises the issue that we need more information about it. And so, I think the one thing in the pandemic, and this is my 4th pandemic, is to keep an open mind. As soon as you close your mind off and you just are going down one path and you're not willing to look at other things, I think that's when you really do a disservice to your
And there's unfortunately been a lot of that. So on one side, no open mind. On the other side, mind so open, brains are falling out, right? So, so this is just a slide I put together with a whole bunch of stuff on here from all the natural agents that you guys have. It's interesting, isn't it, how some of the stuff that works, at least to some degree, in long-haul COVID are the same things that worked in acute COVID. And we went back and mined the data immediately when SARS-CoV-2 came out. A lot of us did, a lot of you in the room, and probably didn't realize how much information there was actually out there on treating coronaviruses, and whether it's some influenza models, there was models from SARS-1 and other previous epidemics or pandemics, looking at things like viral blockers, entry blockers, zinc ionophores, all these different things, whether it's quercetin or polyphenols like resveratrol, or tocotrienols, or antivirals like monolaurin and artemisia, N-acetylcysteine, glutathione, like Dr. Horowitz has mentioned many times. And then repurposed drugs, right? LDN as immune modulators, melatonin, and the like. We talked about ivermectin a little bit. But how about fluvoxamine? That's getting a lot of press now. What do you think about the whole use of something like an SSRI in this situation?
Well, we've used it, and it's been we never do a single drug. We always do cocktails, usually of 2 or 3 drugs, maybe 4 sometimes. Fluvoxamine is very interesting because it is a fact that it inhibits cytokine production on a cell-by-cell basis.
But immediately people said, oh, here they go again, trying to say it's in everyone's heads and they're just depressed. That's right? So it has
it's completely
different mechanism.
From
but a lot of people went there, right?
Yeah. Oh, for sure. And not that may not help some of these, because a lot of patients in our cohort have anxiety, and for good reason. But the fact is, we've seen its effects on individual cytokines, and I think they're real. So it actually kind of took the place of ivermectin in some of our later protocols. But like I said, we've now fallen back to just Moraviroc and statins because of, like I said, the new paper that came out showing its efficacy.
Any other comments on fluvoxamine? Anybody use? Well, you mentioned histamines. Antihistamines, rather.
And this is the one that came out. It was only a case study. There was like 2 patients, right? It wasn't a lot. But I was wondering, reading the stuff on mast cell, whether that was actually the relationship, because a lot of our patients are on, Zyrtec and 10 milligrams of cetirizine with Pepcid to block H1, H2 receptors. They're on luteolin. They're on, a lot of them, in fact, need gastrocron because they've got mast cell activation in their gut. But I'm not surprised, because even in the Lyme patients for Herxheimer reactions with your cytokine storms, you can use antihistamines, and it does block some of them. So.
Gez, have you heard feedback from the community?
Antihistamines are almost a staple with anybody who displays any kind of mast cell symptoms, including myself. I can't get through a day. If I'm 15 minutes, 20 minutes late for my second dose of antihistamines, my H1 and H2, I know my skin starts like boiling and sort of itching all over. I absolutely depend on them to get through. There's actually a study by Paul Glynn, who's a physician at UCLH in London as well, and he published a study looking at efficacy of antihistamines that showed they were very, very effective, H1 and H2, in treating long COVID.
Well, some guy put out this study just recently. This is Bruce's alluded to this several times. This is targeting the monocytic endothelial platelet axis with Maraviroc, which, if you don't know, is conventionally thought of as an HIV drug, and Pravastatin as a therapeutic option to treat long COVID, post-acute sequela of COVID. So you've talked about that. What, in a nutshell, you're using two drugs in combination, Maraviroc, Pravastatin. Just briefly, main mechanism of action of each, and what did the outcomes say?
Main mechanism is our first paper in Frontiers in Immunology showed that there was markers that indicative of vascular inflammation. Our second paper, which was published by Frontiers in Immunology in early January, showed that vascular inflammation was caused by intermediate and non-classical monocytes carrying the S1 protein months, if not years, after infection. We did whole genome sequencing to show that the virus is not replication competent. We found fragments of RNA, so that fits with the NIH study. The NIH study just used PCR, immunohistochemistry, and a lot of techniques that don't show replication competence in tissues. And so now we're doing whole genome sequencing in tissues. So we found the vascular inflammation. We found why there's vascular inflammation, because these cells, which naturally patrol the endothelium, are causing an endotheliitis. And we block the migration of these cells because they can go across the blood-brain barrier and bind. And when they bind, they produce type 1 cytokines, vasodilatation, VEGF, and literally headaches, migraines, brain fog. And so with these combination of two drugs, we looked at 5 accepted symptom scores. Like I said, the New York something neurology score, dysautonomia score, fatigue score, which was the most important, the shortness of breath or dyspnea score, and one other one. But the bottom line is we showed statistically significant reduction in all of those scores in 6 to 12 weeks of therapy. And like I said, most importantly, our biostatisticians correlated the cytokine changes that were associated with improvements in these scores. So now we know which cytokines to target for individual symptoms, and that is the hallmark of our targeted treatment regimen.
Okay, we're down to 1 minute and 26 seconds.
Just one quick question for you, Bruce. Bartonella is one of these co-infections that shows up in my patients quite a bit. And the problem is, I was wondering how much you're seeing it, because there's like 36 different species and subspecies. You can't just look for Bartonella henselae or Quintana or Bacilliformis. There's Elizabethae and all of these subspecies. High VEGF, but we're getting a lot of fish testing that's positive in these patients. And I was wondering, with the high VEGF, are you tracking Bartonella to see if there is any relationship? Because it's a stealth pathogen, you can't always pick it up so easily. And I was wondering if you're finding it in any of these.
Well, when the patients enroll in our program, we may not get as extensive of a report as you might get. We'll get they'll say, oh, I have Borrelia, I have Bartonella, I have Babesia, and we're like, okay, fine, you're, in our words, PASC plus. Or I have EBV, okay, you're now PASC plus. And then I showed at the immunology conference last week how we can use cytokine nodes to divide all of them. So now we can unequivocally parse who's clean, pure PASC, who's PASC plus EBV, who's PASC, which is MECFS in my book, PASC plus Lyme, which is Lyme in my book, and then post-vaccination long haulers. But back to your point, we don't know what the actual species are, but yes, we see definite patterns, and our bioinformatics guys have already worked this out in Lyme. Like I said, I think the two things that set it apart are interleukin 6 and interleukin 8 from long COVID. And believe it or not, when we did a confusion matrix for the machine learning, it was confused with post-vaccination long haulers, not COVID long haulers. So we're looking into that, and it may be because there's persistent antigen in both cases in these long-lived monocytes that are driving the immune response in time. So I think in terms of Lyme, we have to think about, is the organism, the big $64,000 question, as you know, is the organism still there, or are we dealing with the ongoing immune response because there's fragments of the Borrelia peptidoglycan wall, for instance, in monocytes that's being carried for years and years and years. So we're actively collaborating with the Lyme community to at least treat both. We treat the immunology, but we have the proteomic instruments now to look into that question of whether or not there's particular proteins that are being carried for a long time.
All right, we're over time here. You can pull my slides, talk a little bit about plasmapheresis, which we did address a little, but just wanted to say that the last thing here is that long-haul COVID is pitting patients against doctors. This was on Medscape, right? Where on one side you have the long-haul COVID people feeling like it's still not being taken seriously. You still, unfortunately, have some physicians and healthcare providers not really knowing much about this, or some actually claiming, this is craziness, and any of the treatments that they may be trying are totally unproven. And unfortunately, what's happening is a lot of Americans are going overseas for various treatments, and you don't know the quality of some of these places. Some of it may be great, some of it, who knows? They're making claims that are pretty powerful, and part of that is this plasmapheresis type of thing. Now, our Q&A, we had a very limited time, very, very complicated subject. I'm going to ask our speakers when we leave the stage, we're going to go back into the foyer just behind this room and just hang out a little bit on the break, and we can people can come up and ask them questions. I did want to make everyone aware that there's going to be another session in this conference tackling this whole issue of COVID-19, acute and long haul, presented by or sponsored by IFM and presented by my good friend Joel Evans. So don't miss that session for sure. And then if you want to see all these people again, but giving long-form plenary presentations of all of their latest work and research, in October, the CASI conference in Orlando, they will all be speakers, and there'll be many more speakers as well. And we're going to talk about this issue of immune resilience in coping with chronic sequelae of infectious disease. So I wanted to thank my panelists again for making the trip. Please give them a round of applause, and we'll be in the back. Thank you.